So good morning my dear students, I welcome you to NEET world. So today we will be continuing our discussion on EAPCET, APEAPCET question papers of 2025, right? So we have almost done with the paper 1, that is what 2025 May 19th shift 1 paper is done. We are left with 3 questions and after that we will be doing the next shift question, that is May 19th shift 2 paper we will be doing today. Okay, so let us finish these 3 questions first. So for question saying that which are the following compounds give salt of an acid and alcohol on heating with concentrated KOH. So tell me here, so we need to take one compound out of this, so that should give one acid, okay, that should give one acid. So it should be, see, since acid and alcohol, it means it is an organic reaction, see, all of them are organic compounds only. So definitely it should be a carboxylic acid, we can say. Okay, so I am writing carboxylic acid like this. Okay, some R group will be there this side, and along with this we require some alcohol. So these are the products formed, they are saying. Now see, we need to treat with concentrated KOH. So there is only one famous reaction that we know from carbonyl compounds, that is what? Cannizzaro reaction. Yesterday I have given these questions as homework to you, right? So what is that reaction? Cannizzaro reaction. So what happens in Cannizzaro reaction? So without alpha hydrogen, carbonyl compounds should not contain any carbonyl compound should not contain any alpha hydrogens. Then that upon treating with concentrated base, okay. So for example, here in the first case it is formaldehyde, right? So this formaldehyde does not having any alpha hydrogen, whereas acetaldehyde, if you consider the second compound, it will be having methyl group here and a hydrogen here. So now to this carbonyl group, this is the alpha carbon and the hydrogens attached here are alpha hydrogens. So these alpha hydrogens, okay, whenever we are treating with the base, okay, alcoholic KOH or concentrated KOH, here we have now. So this KOH, see, if there is no alpha hydrogens as in the case 1, so this will directly go and attack on this carbonyl carbon, which is electrophile, and now our OH group act as a nucleophile. So this is what the scenario here. But in the carbonyl compounds which are having alpha hydrogen, see, in acetaldehyde we have alpha hydrogen, in acetone also we have alpha hydrogen, in acetophenone also we have alpha hydrogen. So in this case, this KOH act as a strong base and like abstract a proton from alpha position carbon. Okay, so that is what the aldol condensation takes place in these three compounds B, C, D. In 2, 3, 4 options, what happens? Aldol condensation takes place. But here in the case 1, with formaldehyde which is having no alpha hydrogen, so what happens? A disproportionation reaction, that is what? Cannizzaro reaction takes place. Let us look here what happens here. So whenever this is attacking here, so we will be having something like this. So this will goes on, okay, OH group will attack here and like this it will be. Now what happens, you know, this O minus will give its negative charge electrons again back to the carbon. That time this hydrogen will goes out as a hydride ion. So now what it is coming out? We are getting hydride ion outside, and what is the remaining part we have? So we have a carboxylic acid like this. Formic acid we got. What is the acid formed here? Formic acid. Okay. So along with that, so which ion is coming out? Hydride ion is coming out now. So this hydride ion will again react on one more molecule of this formaldehyde. So now I am writing formaldehyde, one more mole here. Okay. So on this nucleophile H minus A nucleophile attacks on the electrophilic carbon and results to form, look here. So what it results to form? Hydrogen, hydrogen, hydrogen. This O minus will goes out upside with a single bond, so like this. So methoxide ion CH3O minus is formed. So what we can call it? So it is a methoxide ion. So methoxide ion will abstract proton from here and results to give us formate ion O minus plus methanol. So we got one alcohol and one carboxylate ion. Okay, so these are the 2 products formed. Okay, where, so now this formate ion is a KOH, potassium salt of carboxylic acid. Now here. So we got a salt of acid, yes, we got a salt of acid and an alcohol, yes, methanol is formed. So formaldehyde is a suitable answer for this question. Hope it is clear what exactly happens in the Cannizzaro reaction. Okay, so Cannizzaro reaction, when it is taking place, so carbonyl compound should not contain alpha hydrogen. Upon treating with base, concentrated base gives one product as carboxylic acid or salt of carboxylic acid, and another one is alcohol. Hope it is clear. So whatever the aldehyde we are considering, whatever the carbonyl compound we are considering, so one mole will be converting into carboxylic acid and the other mole converting into alcohol. So these are the two things happening in this particular reaction. And one more thing what you need to know here, this is an example of disproportionation reaction. It means same species, same substrate is undergoing oxidation as well as reduction. This thing you need to remember. Okay, so there is a PYQ question on those kind of statements also. Which are the following is an example of disproportionation reaction. Okay, so now what are X and Y in the following reaction sequence? Tell me. So you take this X, do partial reduction, so it will be giving Y. So treat with like acidic hydrolysis you do, you can get Z as a major product. Now what are the products here? See, now they also mentioned here, so this X, the starting material X forms sodium alkinide. Sodium alkinide means definitely what it is? So definitely what it is an alkyne. So this is what CH3 I am writing, 4 carbons are there now. So now see here, what is the degree of unsaturation for that? Whenever we have 4 carbons, consider the respective alkane. So with 4 carbons what we will get? C4, okay, so C4, Cn H2n plus 2 now, C4H2n, 8 plus 2, 10. So if it is like this, we can say it as butane. Okay, but here it is having only 6 carbons, it means 6 hydrogens. It means how many hydrogens are less? So 4 hydrogens are less. 2 hydrogens less means 1 degree of unsaturation. So 4 less means 2 degree of unsaturation. If it is 2 degree of unsaturation, so if it is 2 degree of unsaturation, I can say it can be a alkyne, right, or it can be a diene, like that. So I am writing alkyne because they mentioned it as alkinide. Okay, so I am writing alkyne. Okay, CH3, C triple bond CH. Okay, here one hydrogen. So this is one butane I can say. So now this, upon treating with sodium, when we are treating with sodium metal, what happens? So it will take this acidic hydrogen, I mean it will release that acidic proton and it will form this whatever they mentioned, that will be formed here. So CH3, CH2, C triple bond C minus. This is the hint they have given, that's why I am telling you what exactly it is forming here. So this is alkinide, sodium alkinide is formed. Up to here it is clear, I hope. So this is our X now. Okay, so X upon partial reduction. So partial reduction, what it is forming? So partial reduction means, see here triple bond is there now, on complete reduction, so it converts into alkane. What it will be converting? These 2 pi bonds will be removed and 2 hydrogens here and here, 2 hydrogens are added. This is what the transformation takes place. But they are saying partial reduction, it means out of these 2 pi bonds only 1 pi bond will be converts. Okay, it means alkene will be remaining as a product here. See what is the change you have seen here? So 1 hydrogen on this carbon, 1 hydrogen on this terminal carbon were added. Okay, this is the partial reduction product, that is Y, our Y. Okay, so this Y we need to add water in acidic medium. To this Y what we need to add? We need to add water in acidic medium. See, acidic medium means we need to add H plus first. So where this H plus will be added? See, H plus is an electrophile. Okay, so now this is an electron deficient species. Now pi electrons will act as a nucleophilic centers and that will be added, that will be taking this proton. Okay, now what we are getting? We are getting a stable carbocation. Write the stable carbocation here. CH3, CH2, CH, CH2. See, I am adding H plus here and carbocation is generated on this carbon. Okay, secondary carbocation is more stable. So to this we are followed by hydrolysis now. So add H2O to this. So if we are adding H2O, we know H2O is a neutral electrophile. This lone pair electrons will attack on this carbon and generates a alcohol. So what is our alcohol here? CH2, CH3, CH, CH3. See, here we added OH. That's it. That's it. This is what happens here. So remove one H plus from water. Okay. That's it. So check. This is our Z. This is our Z. They are asking about major product only now. So this is our major product. Addition of OH here is a minor. That is again different case. Okay. Now tell me which option we have. Yes. So here we have 1 butane. Okay. And our Z is, so what they are asking, X and Z only now. So our Z is, yes, OH group on this carbon is our major product. Yes. Major product. So this is our major product. Hope it is clear. So option 3 is perfect answer for this. Okay. And if they ask for Z as a minor product, your option 4 should be the answer. Hope it is clear. If you really clear with this concept, please click on the like button so that I can confirm that you are clear with this. Yes. Yeah. Let's move further. So what is the question number here? We have 159. The last question of this paper. Yes. Identify the amide which gives propane 1 amine. So write the structure of this propane 1 amine first. Propane. So propane means 3 carbons. Yes, 3 carbons. 1 amine means on terminal carbon we have to put NH2. Okay. In Hoffman bromamide degradation. So what happens in Hoffman bromamide reaction? Look here. So what happens here is, so whenever we have amide, look here, whatever the carbon alkyl group it is. Okay. Here if we have amide, so in Hoffman bromamide reaction we use generally NaOH, like base plus bromine, like this we will be using. Okay. So now what happens here is, just you need to remove this part. If you remove this part, the remaining part you can add. What is the remaining part? RNH2. So this is our product formed. Similarly, now we need to get this. It means, see, NH2 is there, this is the alkyl group R here. So in between that we need to insert this CO group. That's it. So write this. See, 3 carbons are over. Okay. After this, so here I am putting this CO group and here I am writing NH2 group. So now why I have inserted here? So this is a transformation taking place in Hoffman bromamide now. So just by removing this we can get this product. So we need to look for the option which is having this kind of structure. So how many carbons are there here? 1, 2, 3, 4. See, 4 carbons should be there. Only 3 are there. So these are 4 are there, but this is a branch. We don't require branch. Okay, we require a straight chain. See, 1, 2, 3, 4. Yes. So this is our option. By removing this, we can get our product like this. Look, 1, 2, 3 propane, 1 amine. Hope it is clear. So option 3 is perfect answer for this question. Right? Everything is clear now? Yes. So let us move further. Yes. See, if you have any doubts or any confusion regarding this explanation or anywhere here, so just feel free to ask in the comment box. I am looking into the chat box. Yes, you can write in the comment box or the chat box here. Let us start our new question paper, that is, next shift question paper. So I will be taking it out. So this is, see, this is a paper of 19th May shift 2, 19th May shift 2 paper. So let us solve this question now for chemistry part first, then later in the upcoming sessions you will be, in the continuous sessions you will be having physics, physics and bio parts for bio students and maths for MPC students. Yeah. So these are the chemistry questions only, right? So now we have, chemistry part. I hope you know there are 40 questions. We need to answer all 40 questions and there is no negative marking, right? So let us look into the question number 1, that is 121st question. Again, see, in the same, in the both papers, in the both shifts, the question is on same concept. Okay, that is on this Rydberg's equation. Read the question once. The wavelength of spectral lines corresponding to the electron transition n equals to 3 to n equals to 4 for Li plus 2 ion is lambda. What is the wavelength in nanometer corresponding to electron transition from n equals to 4 to n equals to 1 for helium plus ion. Yes, there are 4 options. So how can we approach this question? Yes, so we need to know what is the relation between these n values and this atomic number and the wavelength. So we have one relation from Rydberg's formula, 1 by lambda equals to RH z square 1 by n1 square minus 1 by n2 square. Yes, you can use this formula and you will get the answer. Okay, so let us by using this, let us find for lithium first. Okay, Li plus 2, I am writing Li plus 2, which is equals to RH. What is the atomic number of lithium? It is 3 na, 3 square means I am directly writing 9 here. Okay, so what is the value of n1? N1, lower number first, n1 is small number, so n1 is here 2. Okay, so 2 square means 4 and n2 is 3 square 9, I am writing like this. Okay, and you can simplify this, so RH into 9, here what we will get? So in the denominator it will be 4 into 9. Okay, 9 minus 4 how much? 9 minus 4 it is 5. Okay, this 9 getting cancelled out, so we are remaining with what? 1 by lambda of lithium plus 2 equals to RH into 5 by 4. This is the one value we have. Okay, so from this lambda of Li plus, what I can write? Li plus 2 equals to 4 by, I just inverted this, so just take the reciprocal or inverse of this, so you will get 4 by 5 or 4 by 5 denominator RH. Okay, this is the value you will get for lithium. Similarly we need to do it for helium. So lambda of helium, you can take lambda of helium plus, so again RH z square value, lithium helium atomic number is 2, so it will be z square means 2 square 4. Okay, what is the 1 by n1 value is? N1 is 1 only. Okay, n1 is 1 only, and what about n2? It is 16, so 1 by n2, it means it is 4 now, so 4 square 16 I am writing here. Hope it is clear what I am making. Yeah, so from this RH into 4, here in this bracket what will get? 16 minus 1 15, you can write like this, so 4 1 ja 4 4 ja. So finally what we are having? Helium, 1 by helium plus is equals to RH into 15 by 4. This is the value we got. I want for helium, this is a 1 by helium. If it is helium, just take the reverse or inverse of this, so 4 by 15 into RH. Yes, we got the values of both of this lithium and helium here. So now take for lithium, the wavelength lambda of this is called directly just lambda. Okay, now they have given for lithium like that, and we have to find it for helium. So for this what I am saying is lambda of helium plus by lambda of Li plus 2 equals to, so what is the value here? We have 4 by 15 RH. Okay, in the denominator there we have here 4 by 15, there also 4 by 5 RH. Okay, RH removed. Okay, so 4 also removed, 5 1 ja 5 3 ja, so what we are remaining with? 1 by 3 we are remaining with. Okay, so now helium plus will be, lambda of helium plus will be 1 by 3 of lambda of lithium plus 2, that's it. So 1 by 3 of lambda of lithium plus 2, see 1 by 3 of lambda will be equals to what? That is a wavelength which is equals to helium plus atom or ion. Okay, helium plus ion. Hope it is clear now. So what is our answer here? Option 2 will be the perfect answer for this question. Now you can take a note of it and you can once again solve this, because these are numerical based questions and formula based questions. Now you should be aware of how we are going to simplify each and every step in order to get exact answer. If you do a small mistake, everything goes wrong. Okay, hope it is went clear, everything is clear here, right? Let us move forward. Next question, total number of orbitals, the orbital with number of total nodes as 3 and angular momentum as 3. So total number of, see, let us say orbital, there is an orbital, sorry, Orbital, there is an orbital with number of total nodes as 3. Okay, so nodes are as 3 and angular nodes as 3. Okay, both are 3 only. So nodes are 3, number of nodes, total number of nodes as 3, and angular nodes is indicated with symbol L, okay, which is equals to angular moment quantum number, that is L equals to 3 they are saying. Okay, here we got. Okay, so now total number of nodes formula is what? N minus 1. So how we got this formula? See, total number of nodes is nothing but total number of radial nodes plus angular nodes. So total number of radial nodes are taken as n minus L minus 1 and angular nodes as L. Okay, so minus L plus L get cancelled, we are remaining with n minus L. This is the value. So total number of nodes is given as 3, okay, and n minus 1. So from this what I am finding? I want to find its n value, principal quantum number. So n will be how much? 3 plus 1, so that will be 4. So n value is 4 and L value is how much? L value is 3. So N4 L3. So L, if L equals to 0 we can say S orbital, L equals to 1 we can say P, L equals to 2 we can say D, L equals to 3 we can say F. So we have n equals to 4 and L equals to 3. It means it is a 4f orbital. Hope it is clear. It is a 4f orbital, right? Yes, everything going well, right? Yeah. Hi sir. Inaya Ansari. Yes, good morning, good afternoon ma. So I hope you are following the class, and if you have any queries in this or any difficulties in understanding the concepts, feel free to ask in the chat box. Yes, okay, I hope it is clear. Now tell me in the comment box. So I wanted to know what are the n value and L values for each of these orbitals, each of these 4 orbitals. Write in the comment box. Okay, yes, let us move further. Which of the following elements are correctly arranged in the decreasing order of atomic radius? Yes, so these are the like elements from the periodic table, right? Look into it. What they are asking, 2 elements are from 2p series, I mean second period, and 2 elements are from third period. Okay, so now how can we answer this question? See, we know in the periodic table from left to right what happens? Atomic radius decreases. From top to bottom also atomic radius decreases. Based on this you can answer easily. Okay, so now carbon, fluorine belongs to same group, right? Same group, I mean same period. So out of this, from moving from here to here, size decreases. So carbon is having larger size than fluorine, right? So from this again, next in the carbon followed by here we have silicon, and we have here we have what? Chlorine. So now here also silicon will be having larger size. So from this now tell me, down the group size increases, along the period size decreases. So silicon should be having larger size, okay, and fluorine should be having least size in this. Okay, like this. Do we have any option like this? Yes, we have only one option like this: silicon with maximum size, fluorine with minimum size, followed by chlorine here and carbon here. That's it. So our option 2 is perfect answer for this. Okay, right. So let us move further. 124. The pair of compounds which have same molecular geometry. So how can we do this? This is again from chemical bonding. Okay, hope every serious aspirant will definitely do this kind of questions, because they should go to the exam only after studying chemical bonding. That much important this chapter it is for JEE, NEET, EAPCET, all the exams, right? Okay, let's try BF3. What is the structure geometry it will be having? So BF3, boron belongs to 13th group now. So 3 valency electrons. So 3 valency electrons plus monovalent atoms are 3. So 3 plus 3, 6 by 2. So you will get 3 again. So it means sp2 hybridization. sp2 hybridization means 3 orbitals are there. So center boron, like this. It is what? now it will be having trigonal planar geometry. What it is? Trigonal planar geometry. And for BF3, halogen, bromine belongs to 17th group. So 7 valency electrons are there here, and for fluorine 3 monovalent atoms. So 10, totally 10 by 2, you will be getting 5. So 5 means, so what is the hybridization? 5 orbitals you have to take. One is S, remaining 3 P, so sp3, and one more is D. So sp3d hybridization. So if it is sp3d hybridization, we will be having trigonal bipyramidal geometry. So in the trigonal bipyramidal, so if you put these 3 atoms, 3 bond pair electrons, see 3 fluorines are there now, center bromine, so it should be like this. Okay, now always remember, out of these 5 orbitals, only 3 are bond forming. Okay, 2 are remaining with lone pair electrons. So you can keep that lone pair electrons in this position like this. Okay, now remaining will be fluorine here, here, here. So now it will be having something like this. If you look into it, so it will be looking like, wow, how it is looking? It is looking like a, how? It is looking like a T shape now. So we should call it as T shape. Okay, what is that? T shape. So that is what the thing you need to remember here. So it will be having a T shape, and it is having trigonal planar shape. So these are not having same molecular geometry, but they are asking about same molecular geometry. So one is false. Okay, and similarly here this is having sp3, sp2, I mean trigonal planar, and this is having pyramidal. This is also not the correct one. 1 and 3 are not the one. Okay, so 1 and 3 here we have removed that. Okay, and now here BaCl2 having sp hybridization, which is linear like this, chlorine, and here xenon fluoride, it means xenon 18th group, so valence electrons are 8, 2 monovalent atoms 5, 10 by 2 it will be 5, so it will be sp3d, but here only 2 bond pair electrons are there. It means, so in the 5 positions around the xenon, so you need to put in 3 bonds in the 3 equatorial positions. Here are lone pair electrons, here and here is fluorine. So it is also getting linear geometry. So like this, xenon like this, linear geometry. So option 2 is perfect one, and also here both of them are having pyramidal geometry. So 2, 4 are the answers. See, 2, 4 are the answer. See, hope it is clear how easily we are solving. And you know, by elimination, like option elimination also you can see 1 here, 3. So 1 and 3 are not correct. So 2 and 3 are also having different. Like that also you can do. You will get only option number 4. Hope it is clear again, right? Next, let us move further. This is again on molecular orbital theory. See, before the exams itself, I have covered all these things. In our sessions, like in the recorded sessions and live sessions. Okay, so you can go through the playlist. If you want to learn about molecular orbital theory, I have explained very detailedly about molecular orbital theory, and even recent times I have covered question which is there in the JEE Advanced also. You can watch it. Okay, so let us solve this question here. Which of the following set are not correctly matched? See, they are saying about their magnetic nature. So remember, oxygen O2 is a paramagnetic substance. What is that? Paramagnetic substance. Now it is having how many unpaired electrons? 2 unpaired electrons are there. Now if I write O2 minus, here out of 16, 2 are unpaired electrons. Now O2 minus means it is becoming 17 electrons. So this is also paramagnetic. Why it is paramagnetic? Out of this 16, 2 are unpaired, so 1 electron will be pairing with this newly added electron, but 1 more electron will be remained unpaired. So with 1 unpaired electrons. Similarly, O2 plus if I write, it is having 15 electrons. Okay, you have to remove 1 electron. Here you need to add 1 electron. If you write minus, if you write plus, remove 1 electron from 16. So now it is having 15 electrons. Now it is also paramagnetic with 1 unpaired electron. Hope it is clear. Okay, so now based on this, now if I add O2 with 2 electrons, so if I write minus 2, it means here we have totally 18 electrons. Now whatever the 2 unpaired electrons are there, that will be paired up in this case, and it is becoming diamagnetic. Hope it is clear. Now based on this, you can answer not correctly matched. See, O2 plus O2 2 again O2 2 plus means what? So O2 2 plus. So from these 16 electrons you are removing 2 electrons. It becomes whatever the unpaired electrons are there you have removed here. So this will becomes diamagnetic. That's it. So hope it is clear. Now based on this you can match it. See, O2 2 plus and O2 2 minus. So those are diamagnetic only now. So O2 2 minus, O2 2 plus, diamagnetic. Yes, this is first one is correct only. Second one, they are asking about not correctly matched. Okay, go to second question, second option. O2 plus 2 and O2. What is this? This is paramagnetic. O2 is para, O2 plus, this is also para. This is also correctly matched. Both are correctly matched. So we need not to tick this because they are asking about not correctly matched. Next, O2 minus and O2 2 minus. See, they are saying diamagnetic. No, O2 minus is para, O2 2 minus is dia. But they are saying both are dia. So this is what you need to tick. Okay, because they are saying not correctly matched. Yes, this is not correctly matched. Next, O2 plus and O2 minus. They are saying again para. See, O2 2 minus is what? O2 2 minus is dia. They are saying para. This is also not correctly matched. So what are our options which we need to tick here which are incorrectly matched are 3, 3 and 4. So 3 and 4 we have option number 3 in the given options. Hope it is clear. Yes. Dilkash, good afternoon ma'am. Yes, so let us do little more new things. Yeah. So now tell me, what about real gas and ideal gases? Yes. So we know ideal gases are those gases, these are hypothetical only, those gases which obeys all gas laws, right? So and finally giving us PV equals to nRT relation. Okay, and whereas real gases, it means true gases which are existing. Okay, so these gases are so these gases are what? So these gases are following for these gases we have van der Waals equation, right? What is that? Van der Waals equation. Okay, so from that real gas exhibit ideal behavior at high pressure and low temperature. Is that correct? The statement 1 is correct or not? No, it is incorrect now. So real gas exhibit ideal behavior at low pressures, okay. So they are saying they are saying high pressures. No, it is at low pressures and high temperature. This is a statement they should give here. Okay, so it means statement 1 is incorrect. Then next, second statement, at high pressure all gas have compressibility factor either less as equals as 1. No, they do not have 1, right? So you can eliminate both of these options. Okay, so we'll see the option here. Yeah, both statements are not correct. Why? Because it should not be equals to 1. They should not behave as ideal. Okay, so like that you can eliminate the options also. Okay, then next here we have 127. Okay, so now this question you can take it as homework. Okay, and we will be solving this in the upcoming session. Okay, hope you are followed the class completely. Okay, take this as homework and give a try from your side. We'll discuss the remaining things in the upcoming sessions. Thank you for watching and happy learning.